Our case study this week features human evolution and is titled A Tale of Three Lice. What a great title. Our objectives are to explain the relationships between human lice and the lice found on other primates, and explain how we can use proxy data to make inferences about events that were not recorded directly in the fossil record. Now, we can get a lot of information from the fossil record. Fossils provide information about shared ancestry and relationships among the taxa. So it gives us information about humans and their relatives, chimps, gorillas, orangutans, and gibbons. And one thing we know from the fossil record and from other types of studies is that the human lineage and the chimp lineage diverged about 6 million years ago. That's going to be an important number to remember. Homo sapiens evolved about 200,000 years ago and were preceded by several other species of hominin. And just to remind you, a hominin is any species that is more closely related to humans than to chimpanzees. And we talked about those in our last lecture. There are limitations of the fossil record, though, questions that the fossil record cannot answer, such as when did hominins lose their body hair? When did hominins begin to wear clothes? So here's a chimpanzee, one of our closest relatives today, and a human. So how can we answer some of these questions? Well, we could examine patterns of hominin distribution and past climate maps. And that does give us information, but it doesn't provide direct evidence. So we're making inferences. We can look for tools used to make clothes. So far, we've found needles that are about 40,000 years old. But this only provides a minimum age for clothing, and finding a needle is pretty difficult. Can lice help? Can lice tell us when hominins lost their body hair or started wearing clothing? So, a tale of three lice. Lice are highly specialized blood-sucking parasites that live on a single host species. Each of our ape relatives hosts one louse species, but humans host three types of lice: the head louse, pubic louse, and the body louse. You can see the three different species, and I know I'm starting to itch already. So let's start with the head lice. Human head lice and chimp lice belong to the same genus. Why did these two lineages, why did these two species of lice diverge? So take a minute to think about one or two hypotheses, write them down. You can always pause the presentation to give yourself a little more time. Don't let me rush you. So possible origin of head lice. One hypothesis is what we call co-speciation, and that's that human head lice and chimp lice lineages diverged at the same time that hominins and ancestral chimps diverged. So that would have been about 6 million years ago right here. So we're saying that when the hominins and the chimps diverged, the lice that were on the hominins were reproductively separated from the lice that were on the chimps. So lots of time for speciation events. Okay, that makes sense. It's logical, but how would you test this hypothesis? Well, okay, hypothesis, human head lice and chimp lice lineages diverged at the same time that hominins and ancestral chimps diverged. To test this, we could compare the DNA of human head lice to the DNA of chimp lice. And in this case, we're looking at a nuclear gene and a mitochondrial gene to estimate when they last shared a common ancestor. So if that's our hypothesis and that's how we're going to test it, what would you predict? That the last common ancestor of chimp lice and human head lice lived approximately approximately 6 million years ago when those two groups diverged. So there's our prediction. Last common ancestor of chimp lice and human head lice lived 6 million years ago. Here are the results of the study. A DNA comparison suggests the most recent common ancestor of chimp lice and human head lice lived 6 million years ago. Yay! So our conclusion is hominins and their head lice co-speciated from an ancestral chimps and their lice population. So when those populations diverged, the lice were reproductively separated. Okay, well, how about pubic lice? So on humans, there are two different species, or three different species, of course. There's human head lice and there's pubic lice. Why did these two lineages of lice diverge? Again, take a minute, think of one or two hypotheses, write them down, pause if you need to. So one possible origin is new niches. When humans lost most of their body hair, that would have created two separate niches, the body hair on the head and the body hair in the pubic region. And that the lice living in these two regions were separated. They were reproductively separated, so any changes in those populations could lead to speciation changes. How would you test that hypothesis? Well, if we're creating a new species, we're creating new niches, and that those two new niches caused speciation, then I would expect that these two species of lice diverged about the same time that humans lost their body hair. So human pubic and head lice lineages diverged because hominins lost their body hair and developed two hair niches. We can compare DNA of human pubic lice to human head lice, again at one nuclear gene and a mitochondrial gene, to estimate when they shared a common ancestor. So what would you predict? All right, so we're looking at when hominins lost their body hair. Hominins didn't even exist. This is when the hominins and chimps first separated, so it would have had to have been less than 6 million years ago after the two populations separated. So our prediction, human head and pubic lice diverged from a common ancestor less than 6 million years ago on a hominin host. Huh? Oh my. DNA comparison suggests that the most recent common ancestor of human head lice and human pubic lice lived 12 million years ago. It's quite a bit more than 6 million or less than 6 million. So what's our conclusion? Well, human head and pubic lice did not diverge on a hominin, did not diverge because two new niches were formed. And what's that evidence that directly supports that? Fossil record isn't telling us anything. This is our answer. It's because human head and pubic lice lineages diverged well before hominins evolved. So then what are the origins of pubic lice? I'm going to show you a phylogenetic tree of lice. And given the phylogeny of select primates and their lice, what is the most likely origin of human pubic lice? We're going to look at that chart and I'm going to ask you that question. So most likely origin of human pubic lice. Okay, here's human head lice. Here's human pubic lice. These lines show us our lineages. So what do you think? All right, so when we look at this, most closely related to gorilla lice. So our correct answer is B. All right, so surprise, human pubic lice belong to the same genus as gorilla lice. DNA comparisons show that human pubic lice and gorilla lice shared a common ancestor 3 to 4 million years ago. 3 to 4 million years ago. That would be right in here, at the time of the Australopithecines. What were those Australopithecines and early gorillas up to? Well, hominins might have picked up lice from early gorillas by sleeping in nests recently used by early gorillas, preying on early gorillas, eating them, because lice are known to jump from prey to predator. So, why were the lice of early gorillas able to colonize hominins? Okay. One possible explanation is that hominins had lost much of their body hair and so had two hair niches. This explanation is still highly speculative. We're going to have to do more research, think of new ways to ask the questions. But let's go to the third species of lice, the body lice. Human head lice and body lice are different morphotypes, so like varieties, belonging to the same species. Human body lice live on clothing and move onto the skin up to 5 times a day to feed. So here's our head louse. You can see same genus, species, it's like a different variety of it. Genus, species, a different variety here. And consider now human head lice and body lice. Why did a completely different variety arise? Again, take a minute, write down an idea. Okay, so an idea is now we have 3 niches. We have hair on our heads, pubic hair, and now we have clothing providing a third niche. So human body lice arose because humans started to wear clothing. How would you test this hypothesis? So if the third niche hypothesis is that human body lice arose because humans started to wear clothing, we could estimate when body lice arose by identifying the most recent common ancestor of all body lice. So what would you predict? The last ancestor of human head lice and human body lice lived, well, if I'm looking for clothes, if I think it's because of a third niche, I'm going to need a reasonable time for hominins to be wearing clothing. And that's not 6 million years ago. Probably not here. I'm gonna say less than 100,000 years ago on a modern human. So there's our prediction. The last common ancestor of human head lice and human body lice lived less than 100,000 years ago. And what's our results? DNA comparisons suggest that the most recent common ancestor of human body lice lived less than 72,000 years ago. So our conclusion is that human body lice arose from the human head lice on Homo sapiens. And these data suggest that clothing might have arisen, around 72,000 years ago. Is this consistent with the other things that we know? Well, it's consistent with our original hypothesis. It's consistent with data like the age of needles showing that clothing existed for at least 40,000 years. So in summary, phylogenetic studies of lice suggest, we're not saying it's proven, we're saying suggest that hominins acquired a second species of louse 3 to 4 million years ago. That would be the pubic lice, which did not correlate with body hair, with the loss of body hair. But body lice, which arose less than 72,000 years ago, could correlate with the development of clothing. It's at the right time, and at least it's on a human species. So these studies provide interesting data, they provide relevant and supporting data, but of course more research, more data is needed before we can find really strong answers to these questions. So in summary, when did hominins lose their body hair and or start wearing clothing? Truthfully, these questions remain unanswered. Lice are providing interesting and relevant data, and new studies, new ways of asking the question will also provide information to answer those questions. So the research continues, but don't forget, never share your hairbrush. And maybe go take a shower now. That concludes week 8, and I'll see you in a future module.